Hello again. Okay, so I know y'all laugh whenever I do this. It won't let me do it before I start the video. Okay, well, anyway. All right, so we're continuing with female reproduction. And so we're going to do oogenesis, okay? And so this is how you make the oocyte, all right? Some places you'll hear them say oocyte or oogenesis, and some people you say oogenesis and oocyte. So I'm of the group, so I say oogenesis and oocyte. So oogenesis is the production of the female gamete, or the egg. That's a weird looking E. The egg, or the ova. And it's not a very quick process. It actually takes years for the ova or the gamete, this female gamete, to be produced. So it takes years for it to actually complete. When you're born, you're kind of started with a set that's ready to go, but then they have to develop through your lifetime. Okay, so it's not a short, you know, 3-month period or 2 to 3 month period like it is with sperm. These take a lifetime to develop. And so this process actually begins in the fetal period. So while you're in your mother's womb, okay, you have something called an oogonia. Okay, these are the the stem cells. And these are 2N, so they have two complete sets of chromosomes. And they multiply by mitosis, and you get more and more of them. Kind of like the spermatogonia, how they mitose, and you have an A cell and a B cell, and the A cell stays, and the B cell gets to progress through. So this is kind of what's going on in the fetal period, except they don't progress. You make all these oogonia. All right, and then the next step is you get something called a primary oocyte, and it's going to develop in something called a follicle or a primordial follicle. And again, these primary oocytes, they have 46 duplicated chromosomes, and these are what are going to eventually go through meiosis. Okay, so they're going to start going through meiosis, and then they just stop. They stall at the first part of meiosis 1, and they're going to stay that way until the female reaches puberty. And then you're going to start to have these eggs progress through meiosis, finish meiosis 1, go through meiosis 2, and develop and be ready to be a mature egg that could possibly be fertilized to form a zygote, or eventually a fetus or a baby. So at birth, women are born with their lifetime supply of these primary oocytes. So again, you have these oogonia, and then you're going to get the production of primary oocytes. I'm going to show you how that happens. And this is what you're born with. You're born with these primary oocytes. When you say lifetime supply, there's tens and thousands of these. Okay, but think about being age 12 through 50. So let's say, hang on. So 50. Let's say that's the average age of menopause minus 12. So that's 38 years of being fertile. You're going to release 1 egg per month. So the ovaries actually alternate. So each month a different ovary releases the egg. And so let's just say, so 38 years, you're going to release 12 eggs a year. So 456 eggs. So you've got thousands, but you're only going to actually release about 500. Okay, so very, very limited number you're actually going to use. So as you reach puberty, and through puberty and on through, from menarche through menopause, some of these primary oocytes get activated. So they get turned on, they get ready to go. All right. And each month, one of these is selected, okay, and there's still some, trying to figure out how that actually occurs. Each month, one of these primary oocytes is selected to resume meiosis 1, because remember, it's been stalled there. Now it's gonna go. So this one special egg each month is going to be chosen to move on through the process. And so what happens after meiosis 1 is you get 2 haploid cells, okay, which means they contain 23 duplicated chromosomes. And these cells are called the secondary oocyte and a polar body. All right? And so the secondary oocyte is a really large cell that keeps all the cytoplasm and all the organelles. And the polar body really just kind of spits out a real small bit of DNA, just kind of spits out the genetic material and very little cytoplasm. This is different than sperm, okay? So when you have the sperm, it's going to divide to 2 equal size cells and then divide again so that you get 4 sperm. With the egg, you take this division and you get a big one and then a little one. And then this divides again with a big one and a little one. All right, and sometimes this one divides and you get a little one and a little one. And so what you're doing is you're trying to save all the good stuff that you would need in order for the fetus, the zygote, once you have fertilization, to have everything it needs to survive until it's implanted into the uterus. All right, so you want to save all your cytoplasm. So whereas the sperm, you were trying to make a real aerodynamic, just packet of DNA that could swim. With the the ova, you're trying to save all the good stuff of the cell so that it can then go through mitosis later on and develop as a person. So the secondary oocyte, right, it's going to stall again. So this is the thing about oogenesis. There's kind of a start, stop, start, stop. And I'm going to show you a nice diagram, I hope, in just a second. So this secondary oocyte is going to stall in the middle of meiosis 2, all right, and that's what's actually ovulated. So it's still not fully developed, okay? So it's still not at that full process of ready to be fertilized, all right? If it doesn't get penetrated by a sperm, it simply breaks down and deteriorates. If it does get penetrated by a sperm, if fertilization occurs, then that oocyte completes meiosis 2. And this is when it's a fully formed ovum, okay? It's a functional gamete with one set of 23 chromosomes. And it gets rid of that little second polar body, that little small bit of genetic material. So this is what this looks like. So here is before birth. You have those oogonium, these stem cells, and they undergo mitosis, and you get these primary oocytes, okay? And they're kind of stalled. So these primary oocytes are going to be stalled, and they're going to be stuck in this meiosis 1. Now each month, from puberty to menopause, these primary oocytes will start to complete meiosis 1. And when they do, you get a secondary oocyte and a polar body. All right? And again, this one is going to stall. It's just going to hang out. Now, this is the one that's going to be ovulated. Once it's ovulated, if it gets penetrated by a sperm, it will then complete meiosis 2 and become a fully formed ovum. Okay, so that's a little different than the way sperm are made. So you kind of get this stop, 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 start, stop, start kind of a process. And you can see, just like with sperm, you had one cell that went to 4. You still get one cell that goes to 4, but only one of them is the actual egg. You get the production of 3 polar bodies. Okay, and those are not genetically capable of being fertilized and becoming a zygote, or then a fetus and a baby. Okay, so we're only going to get one ovum. So one primary oocyte gives you one egg, whereas in sperm, those primary daughter cells, those B cells, those wind up being 4 viable sperm. So that's a big difference between the male and the female. And remember how we talked about the sperm are going to be developing in the testes and those seminiferous tubules, and they're kind of oozing in their nursery, which I said those are those sustentacular cells. And the sustentacular cells are kind of providing the nourishment and protecting those sperm as they're developing. Well, eggs also have a protective area that they're developing in, and that's called the follicle. And the follicles are inside the ovaries. And so the follicles, they develop and change names as the egg develops. So what you're born with are these primary oocytes and primordial follicles, okay? During infancy and childhood, okay, these primary oocytes, they're in arrested development. So you have those primordial follicles, that's what you're born with, okay? At puberty, once that process, that egg is selected, it's starting to move forward into the oogenesis process. You're going to get a primary follicle, and this follicle is going to continue to grow, and it's going to become a secondary follicle, and then finally a vesicular or antral follicle. Now, the way you get the name primary follicle, it has one layer of cells around it. The secondary layer follicle has 2 layers of cells around it. And when it's a mature follicle, this is a mature vesicular or antral follicle, it has this cavity in it called an antrum. It's a fluid-filled cavity. So when you see a follicle that's got a fluid-filled cavity, that's a mature follicle. And this thing in the middle, that's the ovum, that's the oocyte that's developing. Okay? So once this mature follicle I'm sorry, once you have this mature follicle, when you have an ovulation, so here's ovulation, that mature follicle ruptures and kind of spits out the egg. So it's kind of like popping a zip. So it gets real full and full of fluid, and it's able to rupture and can spit that ovum out. And then the ovum has to be caught by the fimbriae of the female of the fallopian tube, of the uterine tube, and be swept into the uterine tube and then on down into the uterus. The follicle will remain in the ovary, but we call it a corpus luteum. And so if there is fertilization, the follicle remains, and we call it a corpus luteum, and it has a really important role in making hormones that help protect pregnancy. If there's no fertilization, it just degenerates and becomes a little piece of scar tissue called a corpus albicans. So I'm going to show you all these steps kind of one by one as we move through this. So just as a review, the main differences between oogenesis and spermatogenesis. In spermatogenesis, you get 4 viable sperm, so one original cell gives you 4 cells. You get an error rate of about 3 to 4%, so it's pretty reliable. You don't usually have too many bad sperm. They're pretty reliable. In oogenesis, you only get from one cell, you get 1 viable gamete. You get those 3 polar bodies that you can't use for fertilization. But there's a large error rate. They're sitting there for a long, long time. They're starting to deteriorate over age. That's one of the reasons you have an increased risk of birth defects as you get older. Trying to get pregnant, the error rate tends to go up. So, 1 in 5 ovum may have something wrong with it. It may not carry on to a viable pregnancy. Again, you have equal divisions in sperm, so you get equal amounts of sperm with cytoplasm and everything, and then you kind of jettison that cytoplasm and make the sperm be aerodynamic. Whereas in the oocyte, you have these unequal divisions, so you have a large cell, those little polar bodies, and this ensures that you've got ample nutrition for that fertilized egg to make it all the way to the uterus, where it's going to implant and then form a baby. So it's kind of like, think about it almost like the egg yolk in an egg. So it's providing the nutrition for that. And we'll talk about how that works when we get the actual pregnancy. Don't worry about the polar bodies. They just kind of degenerate and disappear. They get taken back up by the body. All right. So when we're talking about this oogenesis, so as the egg and the ovary, the egg and the follicle are developing, we call that the ovarian cycle. Okay, so you have an ovarian cycle, which is the development of the egg, and you have a uterine cycle, which is how the uterus thins and thickens up when you're thinking about having your period. So those are 2 different cycles, and we're going to talk about how they work together. So the ovarian cycle is the monthly series of events associated with maturing the egg. Okay, so this is how the egg matures. And it happens in a 28-day cycle. So give or take, I mean, people have anywhere from 25 to 30-something day cycles, but the average is a 28-day cycle. You have the follicular phase, you have ovulation, and you have the luteal phase. So the follicular, ovulation, and luteal. The follicular phase, this is when the follicle grows, and it takes about 1 to 14 days, and it can vary a little bit. Ovulation occurs in the middle of the month, the middle of the cycle. And then the luteal phase is when the corpus luteum is active, and it's from days 14 to 28. Okay, so the first half is follicular phase, you ovulate, and then you're in the luteal phase. And I'm going to take a break. I'm going to stop this particular video. Same PowerPoint, but it's getting a little long, and I've got a lot left to say, so I'm going to break this into 2 parts. All right, so hang on with me, and I'll be right back.